All right, welcome back to another JNCIE-SP video. So in this video, it's going to be more about routing policies for BGP communities. So last video, we finished the exercise, and the exercise was really heavy on ISIS. In fact, it looks like it was configuring a routing policy to redistribute BGP routes to specific community tag in ISIS. So it was more about redistributing a route into ISIS than about IPv4 and IPv6 BGP communities. I mean, I'm sure it's going to be on a pretty big topic on the exam, redistributing those, but it's really not, I think, that complicated of a concept. It's just your export policy is going to be including from protocol ISIS. That's really all there is to it. And then, well, this is what's happening for eBGP. Where's the, okay. Yeah, so your ISIS is exporting. Oh yeah, that's to send it out through BGP. To send it out through ISIS, we use this policy from protocol BGP, perfect. And then any routes tagged with this community EDU are going to be sent out through ISIS. So it's not that much configuration to think about, but we got a kind of a crash course in ISIS. That topic is coming later. But what's important to think about for this topic is how those BGP routes can be filtered out based on their community string, in this case EDU. And then when you export those routes into ISIS, you're only exporting BGP routes with that community string. And then you can set the metric. So we kind of took a tangent and dove into aspects of ISIS, but it's its own very large topic. So just like BGP is its own very large topic. So we're going to be trying to keep on topic here. So let's move on to the next one, configuring a routing policy that removes BGP communities. This example shows how to create a policy that accepts BGP routes, but removes BGP communities from the routes. This example shows two routing devices with an external BGP, eBGP connection between them. Device R2 uses the BGP session to send two static routes to device R1. On device R1, an import policy specifies that all BGP communities must be removed from the routes. By default, when communities are configured on eBGP peers, they are sent and accepted. To suppress the acceptance of communities received from a router, you can remove all communities or a specified set of communities. When the result of a policy is an empty set of communities, the community attribute is not included. To remove all communities, first define a wildcard set of communities. Here the community is named wild. So the wildcard character is the asterisk. Then in the routing policy statement, specify the community delete action. Community delete wild, wild standing for the community name. And the community name referring to a community where everything is the member. To suppress a particular community from any autonomous system AS, define the community AS, community wild members star community values. So you don't have to do it just for all of them. You can also do it just for a specific one, but you'll still need an asterisk. It's just going to be at the beginning of the colon, and then afterward you'll specify the one that you want to suppress. Okay, so let's get started. Luckily, the configuration is really nice and easy. So I think we'll see, yeah, we see here what was above, so that's just going to be included there. So let's get started. I'm going to close those doors. All right. Just less color contrast in the background. So you can see I, in between videos, prepared these to be ready for the configuration relating to this exercise. And of course, it's never fun to just tear down the configuration you did before, but if I had invested more in storage space on my server, I could save hundreds of different topologies. And even as now, with only 900 gigabytes for storage, I can still save like well over 10 topologies. It's just, and that's something I'll probably do. If any really complex topology comes up here, I'll just save it so I have it for later. So here's where we're applying that policy. It's not currently defined. So if I do a commit check now, it'll say I'm applying a policy. It's referenced, but not defined. So let's define that now. So, so community delete wild. So we're going to have a policy, and then the policy is going to delete communities, and this is the name of those communities, which is going to be all communities. And I cannot resize this. Okay, there we go. Perfect. Oh. Oh, it's policy options. Wild. So let's take a closer look at these. So here's all our policy options. Let's see what it says for community. Define, so BGP community information. So name to identify BGP community, wild. And now members, community members. And now just community members, star, colon, star. One thing I would like to do, and I'll do that after committing this, is go and read a bit more specifically about BGP communities, like why is this syntax required, *:*. I was kind of hoping to see that in the help menu, but we can seek that out. All right, so hopefully that'll commit. Perfect. So yeah, let's seek out some more information about BGP communities and try to figure out why that *:* syntax is required, especially that colon. Instead of doing a Google search though, let's try to use the tools that are going to be easily available during the exam. So that's just the built-in help menu. So here we go. Help reference, BGP community. Let's take a look at that. Perfect. So yep, now we've got the exact same documentation that we would have found if we would have done a Google search, but this is going to be readily available during the exam. So let's try to get more information about the target identifier, because that's going to be what includes that special syntax. So, appropriate target identifier. Target by match fire. Aha, so here we go. The format for extended community IDs is the following: type, administrator, assigned number. And these are extended community IDs. So the format for community IDs is AS number, community value. So for the AS number, we're going to have a star. Any AS is perfectly fine. And then community value, we're also going to have a star. Any community is fine. But if you wanted to do a specific community, you would have the AS number be a star for any AS, and then the specific community. But this looks like it's exactly what we were looking for, so I think I'm going to read as much of this as possible. So, description. Define a community or extended community for use in a routing policy match condition. Options. Name. Name that identifies the regular expression. The name can contain letters, numbers, and hyphens, and can be up to 255 characters. To include spaces in the name, enclose it in quotation marks. Invert match. Invert the results of the community expression matching. Members. Community IDs. One or more community members. If you specify more than one member, you must enclose all members in brackets. The format for community IDs is AS number, community value. AS number is the AS number and can be a value in the range from 0 through 65,535. Community value is the community identifier and can be a number in the range from 0 through 65,535. So it looks like both of those AS numbers and community values are going to be numbers. I'm kind of surprised by that because I would have thought that a community value could be a string, but I think I'm thinking about the community string, and I think there's a difference between a community value or a community ID and a community string. A community string is an attribute of BGP, but the community name, sorry, the community ID is for use in routing policy match conditions. This I am going to need to go to Google for. So community ID versus community string. So yeah, I think this is a community string. I don't think they're separate concepts. I mean, this is the kind of thing. Oh, this is for SNMP. I should really put BGP. Here we go, background theory. So this, I think, is going to be useful to read. When communities themselves do not alter the BGP, while communities themselves do not alter the BGP decision-making process, communities can be used as flags, God damn it, in order to mark a set of routes. So this is a community string or community ID. These are all the same things. Upstream service provider routers can then use these flags to apply specific routing policies. For example, local preference within their network. Providers establish a mapping between customer configurable community values and the corresponding local preference values within the provider network. The idea is that customers with specific policies that require the modification of local preference in the provider network set the corresponding community values in their routing updates. A community is a group of prefixes that share some common property and can be configured with the BGP community attribute. The BGP community attribute is an optional transitive, which we'll kind of dive deeper into that because those I mentioned in a previous video, those are essential things to know about BGP attributes, whether they're optional, whether they're required, whether they're transitive, whether they're non-transitive. And transitive means that it's going to persist across an eBGP connection. The BGP community attribute is an optional transitive attribute of variable length. The attribute consists of a set of 4 octet values that specify a community. The community attribute values are encoded within an autonomous system AS number in the first 2 octets, with the remaining 2 octets defined by the AS. A prefix can have more than one community attribute. A BGP speaker that sees multiple community attributes in a prefix can act based on one, some, or all of the attributes. A router has the option to add or modify a community attribute before the router passes the attribute on to other peers. In order to learn more about the community attribute, refer to BGP case studies. The local preference attribute is an indication to the AS which path is preferred in order to reach a certain network. When there are multiple paths to the same destination, the path with the higher preference is preferred. The local value of the default value of the local preference attribute is 100. So let's see if we can learn more about these here. And it looks like, yeah, we can. Okay, that's good. So is there anything about communities in here? Aha, here we go, community attributes. So let's learn some more about that. So, and we can see this transitive optional is used again. So before we dive deeper into this and kind of learn more about that, let's look at this optional transitive terminology and understand more about what that actually means. So this looks like a good educational resource. So we've got attribute categories: well-known mandatory, well-known discretionary, optional transitive, optional non-transitive. Okay, and before I did say that there were the alternative to an optional attribute is a required attribute, but I actually knew this. The alternative to an optional attribute is well-known. There's well-known, there's optional, and then there's well-known mandatory, well-known discretionary, then there's optional transitive, and there's optional non-transitive. So let's read about each one. So well-known mandatory. Well-known mandatory attributes must appear in every update message. It must be supported by all BGP software implementations. If a well-known mandatory attribute is missing from an update message, a notification message must be sent to the peer. Examples of well-known mandatory attributes are AS path, origin, and next hop. Well-known discretionary. Well-known discretionary attributes may or may not appear in an update message, but it must be supported by any BGP software implementation. Examples: local preference, atomic aggregate. Optional transitive. Optional transitive attributes may or may not be supported in all BGP implementations. If it is sent in an update message but not recognized by the receiver, it should be passed on to the next AS. Examples: the aggregator of the route, aggregator, community string, community. Okay, perfect. So this community string, sure enough, is an optional transitive attribute, and optional transitive attributes may or may not be supported in all IBGP implementations. If it is sent in an update message but not recognized from the receiver, it should be passed on to the next AS. So this is why you need to explicitly set up a policy to yank that out of there if you don't want it, because it's a transitive attribute. It will just get passed on unless you do something about that. So the last category is the optional non-transitive. Optional non-transitive attributes may not be supported and will not be passed on if advertised. May or may not be supported, but if received, it is not required that the router will pass it on. It may safely and quietly ignore the optional attribute. Examples: multi-exit discriminator, multi-exit discriminator, route originator ID, route cluster list or cluster list. So if it were that the community string were an optional non-transitive attribute, you would need to set up a policy to remove it, because it's non-transitive. When it's forwarded on to the next BGP neighbor, it will get removed by default. But of course, you wouldn't want that. It's a much better thing that the community string is optional transitive, because then as it gets passed along, every BGP neighbor who sees that route is even ones in another AS, because it'll be passed between ASs as well, is going to see that community string and be able to make extra routing decisions based on the contents of it. So let's read one more thing about the community string. I don't know that I want to read this one. For this command are well-known community. So well-known, mandatory. What does this say? So the community attribute is a transitive optional attribute in the range of 0 through 4,294,964,200. So you're not going to run out of community attributes, although you never know, because they ran out of IPv4 space, and that's a big number. It's 2 to the third 2. I'm actually just curious enough to look at that, so I don't know off the top of my head. So 2 to the raised to the 32nd power. Oh, that's the 22nd. I want the 32nd. So, oh, it's the same value. So you get the same amount of space for a community attribute as you do for a IP address. But of course, it's partitioned into sections, as we saw. So hopefully there'll be an example of a community attributes, which is optional transitive. The community attribute is a way to group destinations in a certain community and apply routing decisions according to those communities. The routing decisions are accept, prefer, and redistribute, among others. So that's in Juniper land, in Cisco land, those are the things you can do. But let's see if it's similar or if it's different in the world of Juniper. So you can use route maps to set the community attributes. The route map set command has this syntax. A few predefined well-known communities for use in this command are no export, do not advertise to eBGP peers, keep this route within the AS. No advertise, do not advertise this route to any peer, internally or external. Internet, advertise this route to the internet community. Any router belongs to this community. Local AS, use in confederation scenarios to prevent the transmit of packets outside the local AS. So, and that's a special additive keyword, which only has to do with Cisco. But let's see if we've got these no export, no advertise, internet, and local AS. So this is for, let's see here, community number. So it's kind of the equivalent. This actually looks like something that's good to look at. Because that's the usage guidelines. I'd like to read this part. Oh, here we go. No export, no advertise. So you can see there are similar options under community options community. So if I do a show configuration, type display set, and then go to configure private, edit policy options, community, show pipe display set. So edit policy options, and then community. Let's go into wild again. Set members. Well, that's not going to be the equivalent. I mean, it's a different device. This is Juniper. This is Cisco, and this is where they're okay. So they're doing route mapping here. So this is going to be a different equivalent section. It's going to be in the let's see, our top show pipe display set relative. It's going to be more in the so this is remove communities. So import remove communities. So I think it will be it'll be here where we've got community delete wild. I think we'll have those kind of default options showing up there. So one option you can do instead of specifying a custom community in your policy options is just choose from the ones that are available by default. Well, yeah, I think they're just not closely related enough, Juniper and Cisco. Like, I'm not sure if these are gonna be predefined on a Juniper the same way they are on a Cisco. So just gonna go top, roll back 0, exit, and take a look at that help doc again and see where it was talking about. Because yeah, it did look like, yeah, there's no export. So I think I just need to read this because this looks like it's pretty good, and then I'll go and read the related documentation it suggests as well. So I already did read quite a bit of it, but I'll start here. You can also specify community IDs for communities as one of the following well-known community names, which are defined in RFC 1997 BGP communities attributes. So this is kind of the key RFC, it looks like, that's going to be all about BGP communities. So I definitely will have wanted to at least look this over a little bit before I go into the test. And then I'm going to want to have, of course, read this and then finish up this exercise, of course. So, okay, so the following well-known community names. Oh, I wish I didn't use that word well-known, because that, I wish I used common, because we know that we've got optional attributes, we've got well-known attributes. So well-known are well-known mandatory and well-known, I forget what the other one, discretionary. So there's well-known mandatory and there's well-known discretionary, and then there's optional transitive and optional non-transitive. So that's why I wish they didn't use this well-known there. So we've got no export. Routes containing this community name are not advertised outside a BGP confederation boundary. No advertise. Routes containing this community name are not advertised to other BGP peers. No export subconfed. Routes containing this community name are not advertised to external BGP peers, including peers in other members' ASs inside a BGP confederation. You can explicitly exclude BGP community information with a static route using the none option. Include none when configuring an individual route in the route portion of the static statement to override a community option specified in the default portion of the statement. The format for extended community IDs is the following: type, administrator, assigned number. Type is the type of extended community and can be either a bandwidth, target, origin, domain ID, source AS, or RT import policy, or a 16-bit number that identifies a specific BGP extended community. The target community identifies the destination to which the route is going. The origin community identifies where the route originated. The domain ID community identifies the OSPF domain from which the route originated. The source AS community identifies the autonomous system from which the route originated. The RTM import community identifies the route to install in the routing table. Note, for source AS, you can specify only an AS number and not an IP address. For RT-import, you can specify only an IP address and not an AS number. Administrator is the administrator. Well, thanks, Help Doc. It is either an AS number or an IPv4 address prefix, depending on the type of extended community. Assigned number, right here, identifies the local provider. The format for linking a bandwidth with an AS number is bandwidth, AS number, bandwidth. AS number specifies the AS number and bandwidth specifies the bandwidth in bytes per second. So, okay. So I think that's all there is to read there. I could just read this extra stuff, but I don't really see the need to, especially with all the other reading that I'm going to need to do. I've got a whole RFC here. It looks like it's a pretty short one, though. Yeah, so let's take a look at this one because it's pretty short. Status of this memo. This document specifies an Internet Standards Track protocol for the Internet community and requests discussion and suggestions for improvements. Okay, so we don't need to read that. Here we go. Introduction. BGP supports transit policies via controlled distribution of routing information. Mechanisms for this are described in 1 and have been successfully used by transit service providers. And this is the classic RFC, a border gateway protocol, which kind of makes sense that it's named that because this is the only border gateway protocol for IGPs. An EGP, external gateway protocol, all you get is BGP. I'm actually surprised there aren't contenders, especially for something that is so old. You can see this RFC was originally published in March 1995. So I don't know where all the scientists and engineers went since then, why they're not looking into this further and just continuing to use it. But they have of course added extensions to it. So this was actually made obsolete by this one here. So this is 2006, and then there's constant updates on it. So that's one thing I actually didn't notice, and that is going to be really important to keep an eye on is this right here. In fact, let's see if this one has been rendered obsolete. So it hasn't been made obsolete, but it does have updates. So let's check the updates. I think one is going to be for extended communities. So we've got revised error handling, and we've got policy behavior for well-known BGP communities. So these are the Well, let's not get ahead of ourselves. I mean, it's a short one, but I think this is going to be very valuable to read. BGP, okay, yeah, and have been successfully used by transit service providers. However, control over the distribution of routing information is presently based on either IP address prefixes or on the value of the AS path attribute or part of it. To facilitate and simplify the control of routing information, this document suggests a grouping of destinations so that the routing decision can also be based on the identity of a group. And this makes sense because, you know, let's say you've got 5 things. Like, yeah, you can say, like, I want this thing to do that, that thing to do that. But let's say you have 5 billion things. You know, you can't tell one thing to do. There's just so many things unless you categorize them and say, oh, well, half of these billion things are things I want to do that. The other half are there. And then whichever of those billion things came in through the door on the left and whichever came in the door on the right tells you what group they're in, then you can make decisions. So it makes sense that you would want a further mechanism to make decisions about individual routes in a routing protocol designed to have millions of individual routes or hundreds of thousands of individual routes, because you really want to be able to group them together and affect them large groups of the routes and not have to worry about individual routes when you have so many. Such a scheme, so however, control over distribution of routing information is presently based on either IP address prefixes or on the value of the AS path attribute or part of it. To facilitate and simplify the control of routing information, this document suggests a grouping of destinations so that the routing decision can also be based on the identity of a group. Such a scheme is expected to significantly simplify a BGP speaker's configuration that controls distribution of routing information. Definitions and terms. Community. A community is a group of destinations which share some common property. Each autonomous system administrator may define which communities a destination belongs to. By default, all destinations belong to the general Internet community. Examples. A property such as NSFNET sponsored -AUP could be added to all AUP compliant destinations advertised into the NSFNet. NSFNet operators could define a policy that would advertise all routes, tagged or not, to directly connected AUP compliant customers and only tagged routes to commercial or external sites. This would ensure that at least one side of a given connection is AUP compliant as a way of enforcing NSF transit policy guidelines. In this example, we have just eliminated the primary motivation for a complex policy routing database that is used to generate huge prefix and AS path-based filter rules. And this is what I was talking about earlier. We have also eliminated the delays caused by out-of-band maintenance of this database, mailing in NACRs, weekly configuration runs, etc. A second example comes from experience with aggregation. It is often useful to advertise both an aggregate prefix and the component, more specific prefixes that were used to form the aggregate to optimize next hop routing. These component prefixes are only useful to the neighboring BGP peer or perhaps the autonomous system of the neighboring BGP peer. So it is desirable to filter this information by specifying a community attribute that the neighboring peer or peers will match and filter on. There are more specific routes that may be advertised with the assurance that they will not propagate beyond their desired scope. Communities attribute. This document defines the community's path attribute. This document creates the community paths. The community path attribute is an optional transitive attribute of variable length. The attribute consists of a set of 4 octet values, just like an IP address, each of which specify a community. All routes with this attribute belong to the communities listed in the attribute. The communities attribute has a type code 8. Communities are treated with 32-bit values, just like an IP address. However, for administrative assignment, the following presumptions may be made. The community attribute values ranging from 0 through, so it's going to be 128, 64, 32, 16, so 15. And so from 0 through 15, and from, let's see here, so it's going to be 160, 196 plus 16. Well, anyway, between these are hereby reserved. The rest of the community attribute values will be encoded using an autonomous system number in the first 2 octets. The schematics of the final 2 octets may be defined by the autonomous system. Example, AS690 may define research, educational, and commercial community values that may be used for policy routing as defined by the operators of that AS using community attribute values, this one through that one. Well-known communities. The following communities have global significance and their operations shall be implemented in any community attribute aware BGP speaker. Okay, so we should have these in our Juniper somewhere. No export. All routes received carrying a community's attributes containing this value must not be advertised outside a BGP confederation boundary. A standalone autonomous system that is not part of a confederation should be considered a confederation itself. No advertise. All routes received carrying a community's attributes containing this value must not be advertised to other peers. No export subconfed. All routes received carrying a community's attributes containing this value must not be advertised to external BGP peers. This includes peers in other members' autonomous systems inside a BGP confederation. Operation. A BGP speaker may use this attribute to control which routing information it accepts, prefers, or distributes to other neighbors. A BGP speaker receiving a route that does not have the community's path attribute may append this attribute to the route when propagating it to its neighbors. A BGP speaker receiving a route with the community's path attribute may modify this attribute according to the local policy. Aggregation. If a range of routes is to be aggregated and the resultant aggregates attribute section does not carry the atomic aggregate attribute, then the resulting attribute should have a community's path attribute which contains all communities from all of the aggregated routes. Applicability. The community's path attribute may be used with BGP version 2 and all subsequent versions of BGP unless specifically noted otherwise. Security considerations are not discussed in this memo, but I would guarantee that there are all kinds of security considerations with this. Unfortunately, this is not a security exam, so I won't really be looking into them. But let's see where it's talking about RFC 1997. Okay, so just there for more BGP related information. All right, so I think we've just got one more thing to read. Hopefully it will take only a few minutes. So understanding BGP communities and extended communities and large communities as routing policy match conditions. A BGP community is a group of destinations that share a common property. Community information is included as a path attribute in the BGP update messages. This information identifies community members and enables you to perform actions on a group without having to elaborate upon each member. You can use community and extended communities attributes to trigger routing decisions such as acceptance, rejection, preference, or redistribution. You can assign community tags to non-BGP routes through confederation for static, aggregate, or generated routes, or an import routing policy. These tags can then be matched when BGP exports the routes. A community value is a 32-bit field that is divided into two main sections. The first 16 bits of the value encode the AS number of the network that originated the community, while the last 16 bits carry a unique number assigned by the AS. This system attempts to guarantee a globally unique set of community values for each AS in the internet. Junos OS uses a notation of AS number : community-value, where each value is a decimal number. The AS values of 0 and 65,535 are reserved, as are all of the community values within those AS numbers. Each community or set of communities is given a name within the Edit Policy Options configuration hierarchy. The name of the community uniquely identifies it to the routing table and serves as the method by which routes are categorized. For example, a route with a community value of 64,510 : 1,111 might belong to the community named AS 64,510-routes. A community name is also used within a routing policy as a match criterion or as an action. The command syntax for creating a community is policy-options, community name members, community IDs. Community IDs are either a single community value or multiple community values. When more than one value is assigned to a community name, the routing device interprets this as a logical AND of the community values. In other words, a route must have all of the configured values before being assigned a community name. So the community name is going to be something more plain text, but the community value is going to be where it's AS number and community value. The regular community attribute is 4 octets. Networking enhancements, such as VPNs, have functionality requirements that can be satisfied by an attribute such as a community. However, the 4-octet community value does not provide enough expansion and flexibility to accommodate VPN requirements. This leads to the creation of extended communities. An extended community is an 8-octet value that is also divided into 2 main sections. The first 2 octets of the community encode a type field, while the last 6 octets carry a unique set of data in a format defined by the type field. Extended communities provide a larger range for grouping or categorizing communities. The BGP extended communities attribute format has 3 fields: type, administrator, assigned number. The routing device expects you to use the words target or origin to represent the type field. The administrator field uses a decimal number for the AS or an IPv4 address, while the assigned number field expects a decimal number no larger than the size of the field, 65,535 for 2 octets, or 4,294,967,295 for 4 octets. When specifying community IDs for standard and extended community attributes, you can use Linux-style regular expressions. The only exception is for VPN and import policies, VRF-import, which do not support regular expressions for the extended communities attribute. Regular BGP communities attributes are a variable length attribute consisting of a set of 1 or more 4-byte values that was split into 16-bit values. The most significant word is interpreted as an AS number, and the least significant word is a locally defined value assigned by the operator of the AS. Since the adoption of 4-byte ASNs, the 4-byte BGP regular community and the 6-byte BGP extended community can no longer support BGP community attributes. Operators often encode AS number in the local portion of the BGP community. That means that sometimes the format of the community is ASN:ASN. With a 4-byte ASN autonomous system number, you need 8 bytes to encode it. Although BGP extended community permits a 4-byte AS to be encoded as the global administrator field, the local administrator field has only 2 bytes of available space. Thus, 6-byte extended community attribute is also unusable. To overcome this, Junos OS allows you to configure optional transitive path attribute, a 12-byte BGP large community that provides the most significant 4-byte value to encode autonomous system number as the global administrator, and the remaining 2 4-byte assigned numbers to encode the local values as defined in RFC 8092. BGP large communities attribute. You can configure BGP large community at the edit policy options community name members and edit policy options static route IP address community hierarchy levels. The BGP large community attributes has 4 fields: large, global administrator, assigned number, assigned number. So the length of the BGP large communities attributes value should be a non-zero multiple of 12. Okay, and that's everything. Lunchtime video is over. Thanks for watching. We learned all about community attributes. We configured the first router in the second exercise, so stay tuned for more.